Hello everyone, my name is I'm from NTHU University, and the topic of my talk today is what if Planet 9's current lead is perihelion? So first of all, I would like to thank all co-authors for their significant contribution to this work, especially Amos Chen and Kosat Wu. They are two outstanding graduate students who start Planet 9 research and make a collaboration with other co-authors before I joined this project. So, to understand why Planet 9 and why we start with this research, let's back to more than 10 years ago, when people try to analyze the orbit of minor object in Kuiper Belt. They found that this object has peculiar orbital clustering, not only in argument of perihelion, but also in physical space. So, it's weird, right? Imagine every people work in the Taipei main station on the same way and look at the same direction. So it's impossible. There must be a reason behind that. So we apply the same logic here. This orbital clustering cannot happen randomly unless it's related to another unknown dynamical mechanism. So one famous simulation work by Madigan and Brown in 2016, they suggest that the probability for this orbital clustering happen due to chance is only 0.007%, which is almost impossible. And they also suggest that a giant distant planet with at least 10 Earth mass and semi-major axis of 700 AU can maintain this orbital clustering. So that's how they come up with the Planet 9 hypothesis. But unfortunately, so far there has been no observational evidence for the existence of Planet 9. So if in the near future we can confirm the existence of Planet 9, then it will change our structure of the solar system. Indeed, since the discovery of Uranus and Neptune, and then the demotion of Pluto, we haven't found any new planet in the solar system. But what if there's another planet located very far away from the Neptune orbit? And could it be formed in the inner solar system at the beginning and then later got ejected from to the outer solar system by the gravitational interference of the giant planets like Jupiter and Saturn? That we don't know, right? So one most important task is to confirm the system of Planet 9. So actually, in the past, there are a lot of research groups search for Planet 9 using optical surveys. But turns out they only constrain the possible orbital parameter of Planet 9 without successfully propose any specific candidate. So why? Here's the reason. Because the sunlight needs to travel twice from the sun to Planet 9 and then reflect back to the Earth. So the optical light degenerates faster than the thermal emission from Planet 9 in infrared. So that's why we would like to take advantage of the infrared surveys to search for Planet 9. And one more thing is the location of Planet 9 is uncertain, which means we don't know where it is on its orbit. So that's why we need over sky surveys to have a larger search radius. And here, there are two over sky surveys using the infrared astronomical satellite and Archery space telescope that can meet this requirement with their far infrared filters. So here I want to emphasize that the Archery bright source catalog in the public archive, they didn't include the moving source, so it's not good for Planet 9 search. But so instead we prepare and use another dedicated source list for Planet 9 search, which is Archery monthly unconfirmed source list. It includes the moving source, and then it's good for Planet 9 search. So thanks for Dr. Yamamura and Dr. Nagagawa from JAXA, they are two collaborators of this project for providing us the data of MUSL. And the epoch difference between IRAS and Akari is 23 years, so it's large enough to detect the slow motion of planet 9. So we expect that planet 9 first detected in IRAS, and then after 23 years, it moves slowly to another Akari position. So the general strategy here is, first we remove the stationary source, right source, and source match with other well-known catalog, and then we exclude the galactic plane and galactic pulse region, because these two regions affect significantly to the velocity measurement. And if planet 9 located in this region, so unfortunately we miss it in this work. And then we make a list of single IRAS and Akari detection. And then next, we search for object move slowly from one IRAS position to another Akari position. But we have to make sure that they above the detection limit of IRAS and Akari. And then we make a candidate pair that include one IRAS source and one Akari source within the angular separation range of 42 arc-minutes to 166 arc-minutes. So this corresponding to the distance range of 280 to 700 AU. And then we want to check the IRAS and Akari image. So here's the good example. So the source first detected in IRAS in 1983. And then after 23 years, it's absent from the same position in Akari image, and we expect it will move to Akari position. But because here, because here you may wonder why there's no source here, right? But because this is the public archive image, so it's generated by co-adding multiple scans over several months. So if you enter the coordinate of Akari and MUSL when you co-adding multiple scans, then it may not be visible here in the same position because the source in Akari and MUSL is moving source. So we expect it will not be detected at the same position after several months. So that's why there's no visible source. They may not be visible here. But when we check the Akari probability detection map, we still can see the detection. So here I will show you the full image of the Akari detection map. So you can see two detections on the same day here. But on the date of 6 months before, there's no detection. And this is consistent with our expectation about planet 9 motion, and also consistent with the characteristic of the Akari and MUSL. So our recent work already report this candidate, and it was accepted for publication in PASA. So it's a great honor to have our paper featured on more than 30 news media, including Science Magazine, ABC News, and Space.com. I think it's a great opportunity to promote our research to more audience. But there's a side story. At the beginning, when I received the interview invitation from Science Magazine, actually I declined because of the class and the group meeting, and my supervisor like, huh? Why you can decline such a good opportunity to be famous, to be on the Science Magazine? But anyway, he brought me back to the interview, and that's why we still have the science article here. So after this paper, what's the next step? Because the IRAS and Akari detection are not enough to detect to determine the full orbit of our candidate. So that's why we need follow-up observation. For example, like Subaru HSC and dark energy camera with larger field of view to identify the Kepler-Uranian motion of our candidate. And we also estimate the angular separation range over 19 years between the epoch of Akari 2006 to present. So, in summary, we already took advantage of 5 infrared survey to search for planet 9, and we found one promising candidate in 500 to 700 AU. We need follow-up observation to determine the full orbit of our candidate. And currently, we also continue to search for planet 9 in a closer distance range from 280 to 500 AU, because we believe that if planet 9 is currently approaching or passing its predicted perihelion, then we still have a chance to detect it in the second study. So that's all of my talk. Thank you very much.
So your videos study is based on that the planet 9 is currently near the perihelion passage.
No, we want to cover the large distance, like from 280 to 700 AU, because in the simulation work they predict that the planet 9 should have semi-major axis of 700 AU, and then from that value and the eccentricity we can derive the perihelion and aphelion. Yeah, but we cannot go further than 700 AU because at that distance the flux will be lower than the detection limit of Alaska and Akari. So currently we report one candidate between 500 AU to 700 AU, and then we continue to search for closest range to cover.
Okay, so one question.
Yes.
So in your work, what is the expected penalty for the planet 9?
Sorry?
What is the expected penalty in the infrared?
You mean the
penalty?
the flux, right? So the flux is about 0.5 yards speed, around 0.3 to 0.5 yards speed. Yes.
So let's send the speaker.